Okay, let me share the slide. Alright, so it's about 15 minutes. If you feel tired or maybe you feel sleepy, you can take a coffee. Okay, listen your friends' presentations while taking a simple note. Okay? Actually, you get something from it because after that, you will have a simple quiz. Same as previous, the quiz only have 2 questions. Okay, the basic one. Okay, so if you focus, I believe you can answer the question. Alright, good. Let's start with the presentations. Let me check that you have a same view from me. Alright, okay.
Assalamualaikum. Today I'm from group A4. We'll explain about software design.
Okay, wait. I think I need to change the volume first. Change to music mode will be clear voice. Okay. So I close my camera first so that there is no lagging.
Assalamualaikum. Today I'm from group A4. We'll explain about software design principles. Topic outcomes: to introduce the process of software design, to describe the different stages in the design process, to show how object-oriented design strategies, to discuss some design quality attributes. Developer approach: skip requirement engineering and design phase and start writing code. Why? Design is a waste of time. Need to show something to the customer real quick, judged by amount of log per month. Expect or know that the schedule is too tight. Design is not programming. Design is not modeling. Modeling is part of the architecture design, part of requirement. Requirement is what the system is supposed to do. Design, how the system is built. First level design, the most way effective to enable stakeholders to understand, reason, and communicate about the system before it was built. A high-level model of a software system. Describe the structure, functionality, and characteristics of the software system. Understandable to many stakeholders. Allow evaluation of the system properties before it is built. Provides well-understood tools and technique for constructing the thing from its blueprint. Intermediary level of design. Useful tools and technique implement architecture in a that way that present its properties is a software system blueprint consists its component, their interaction, their interconnection. Design detail level. Aspects that are relevant in terms of architecture in software system are: we design the software, but we must consider the hardware and the environment. Design must reflect requirement, and we must able to relate each requirement with part of the design. Software design. A meaningful engineering represent of something that is to be built, deriving a solution which specifies software requirement. An iterative process transforming requirements into a blueprint for constructing the software. Software design principles should not suffer from tunnel vision, traceable to the analysis model or requirements, reinvent the wheel, minimize the intellectual distance between the software and the problem as it exists in the real world, Exhibit uniformity and integration. Be structured to accommodate change. Software and design principles should be structured to degrade gentle even when aberrant data events or operation conditions are encountered. Design is not coding. Coding is not design. Design should be assessed from quality as it is being created, not after the fact. Review to minimize conceptual scientific errors. Software design fundamental concept, that is abstraction, architecture, pattern, hierarchical structure, adaptability, understandability, limit complexity, information hiding, separate of concern, modularity, that is coupling and cohesion. The design process, informal to formal design. Systems should be described at several different levels of abstraction. Design takes place in overlapping stage. It is artificial to separate it into distant phase, but some separation is usually necessary. Design stage. Problem understanding. Identify one or more solutions. Describe solution abstractions. Repeat process for each identified abstraction until the design is exceeded in primitive terms. Process phase. Architecture design. Identified subsystem. Abstraction specification. Specified subsystem. Interface design. Describe subsystem interface. Component design. Decompose subsystem into components. Data structure design. Design data structure to hold problem data. Algorithm design. Design algorithm for problem functions. From requirement to architecture. Determining exactly what the customer and user want. Specify what the software product is to do. Requirement specification to architecture is planned to design the system, decompose software into modular with interface, specify high-level behavior, interaction, and non-function properties. From requirement to architecture, consider the key trade-off, which is schedule versus budget, cost versus robustness, fault tolerance versus size, security versus speed. Maintain a record of design, decision, and traceability. Specify how the software product is to do its task from design to programming. Advantages of explicit architecture. From requirement to design is from design to programming, testing, and maintenance. Stakeholder communication is architecture may be used as a focused discussion by system stakeholders. System analysis is mean that analysis of whatever the system can meet in non-functional requirement is possible. Large-scale reuse is the architecture may be reused across a range of systems. Architecture and system characteristics. The system must be designed to achieve performance, security, safety, reliability, availability, maintainability, and quality. Architecture design process. System structuring. A system is decomposed into several principal subsystems and communication between these subsystems are identified. Modular decomposition is the identified subsystems are decomposed into modules. Control modeling is a model of the control relationship between the different parts of the system is established. Quality. Design quality is an elusive concept depend on specific organizational priorities. A good design may be the most efficient, the cheapest, the most maintainability, the most reliability, etc. The attributes discussed here are concerned with the maintainability of the design. Quality characteristics are equally applicable to function-oriented and object-oriented design. Abstraction, procedural. Procedural abstraction, natural consequence of stepwise refinement, name of procedural denotes sequence of action. The design concept, abstraction data abstraction, aimed at finding a hierarchy in the data, modularity. Structure criteria, which tell us something about individual module and their interconnection. Cohesion is the glue that keeps a module together. Coupling is the strength of the connection between motion. A measure of how well a component fits together. A component should implement a single logical entity or function. Cohesion is a desirable design component attribute, as when a change has to be made, it is localized in a single cohesive component. Various levels of cohesion has been in the cohesion levels. Coincidental cohesion, which is part of a component, are simply bundled together. Logical association with components which perform similar functions are grouped. Temporal cohesion, which is components which are activated at the same time, are grouped. Procedural cohesion, which the element in the component make up a single control sequence. Communicational cohesion, medium, is all the elements of the component operate on the same input or produce the same output. Sequential cohesion, medium, is the output for one part of a component is the input to another part. Functional cohesion, strong, is each part of a component is necessary for the execution of a single function. Object cohesion, strong, is each operation provide functionality which allow object attribute to be modified or inspect. Coupling, a measure of the strength of the interconnection between system components. Loose coupling means component change are unlikely to affect after components. Share variable or control information exchange lead to tight coupling. Loose coupling can be achieved by state decentralization, as in object and component communication via parameter or message passing. Coupling and inheritance. Object-oriented systems are loosely coupled because there is no shared state and object communication using message passing. However, an object class is coupled to its superclass. Change made to the attribute to operation in a superclass propagate to all subclasses. Such change must be careful control. Information hiding. Each module has a secret. Design involves a series of decisions. For each such decision, wonder who needs to know and who can be kept in the dark. Information hiding is strongly related to abstraction. If you hiding something, the user may abstract from the fact. Coupling is the secret decreased coupling between a module and its environment. Cohesion is the secret is what binds the part of the module together. Top-down design. In principle, top-down design involves starting at the uppermost component in the hierarchy and working down the hierarchy level by level. In practice, large system design is never true Some branches are designed before others. Design reuse experience and sometimes component during the design process. Understandability. Related to the several component characteristics is cohesion, naming, documentation, and complexity. Informally, high complexity means many relationships between different parts of the design. Hence, it is hard to understand. Most design quality metrics are oriented toward complexity measurement. They are of limit use. Adaptability. A design is adaptable if its components are loosely coupled. It is well documented and the documentation is up to date. There is an obvious correspondence between design level, design visibility. Each component is a self-contained entity, tightly cohesive. To adapt a design, it must be possible to track the link between design components so that change sequence can be analyzed. So that's all for this chapter. Thank you.
Okay, let me share the link for the understanding level of the chapter. Can copy in the chat box. All right. Okay, you may start voting for the understanding. Group 4 doing the video presentation for this topic also can do a vote. Now we have 20 votes. $29. Last vote. Now we have 47 minus me to 45. Wah, ramai tak datang hari ni Supposedly we have 53. Okay, dah cuti awal lah. Alright, we already have enough voters. So, one person say yes. Okay, and 97% understand half. Okay, half and below lah. Okay, and that's good. No one say no. Alright. So hopefully the 97% who already halfway understand can be more understand after my explanations. Right. Okay, that's the purpose lah. Okay, let me share the link for quiz first. Okay. So I will open quiz for 5 minutes. 2:32 now until 2:33. Okay, 5 minutes 2:38. Okay, I will close the quiz 2:38. Just a simple quiz. If you done the quiz, you may take 5 first while waiting the others to done the quiz first. Alright, one person already complete, 2% complete the quiz. Five. Okay, 14. Supposedly we will have 47 response. Okay. Twenty. Five, done. Twenty-nine. Okay, 44. Okay, we have 1 minute more. Okay, 45 already done the quiz. 46. I think that we have 46 participants. Okay. All right. Anyone else have not yet done the quiz? If no objections, I will close the quiz now. Anyone? One.
Buat lagi.
Huh? Masih buat lagi?
Tak boleh. Mana dia punya link?
Mana dia punya link baru masuk?
Saya pukul 2.30 baru masuk.
Ha, kenapa lambat tu? Kelas kita pukul 2 bukan 2.30 Itu pun saya start lewat pukul 2. Okay, check the chat box. Last 1 minute. Okay, so we already have 47 response. Let me stop accepting the response first and share with everyone the result here. Okay, not bad. Okay, most of you get the correct answer. Okay. So first questions. Okay, design is not coding. Coding is not design. True or false, right? So 89.4% answering correct answer. True, right? Ni 5% choosing false. Okay, so design is not coding. Same goes to coding is not design. Coding is coding, design is design lah. Okay. Second question, which of the following design concept represent compartmentalizations of data and function? Okay, this is to divide into a few compartment or department, right? So which one? Okay, so the answer is modularity. Okay, still the majority answer correctly, modularity. So not a functional independence, not hiding and not refactoring. Okay, the answer is modularity. Okay, you break into a few parts, okay, or compartment. Yeah. All right. Good. Okay. Thank you for completing the quiz. Okay. So let me share to this slide first. Okay. Remember what we have learned so far. Okay. We start with the introduction. What is software engineering? Right. And then in second topic is on the process. Okay, before you start the project, you should know the process. Okay, and then last week, okay, we have been introduced a new chapter which is RE, requirement engineering. Okay, remember overall process. Okay, following the syllabus that giving to us. Okay, okay, wait, let me share the screen first. Okay. So following the syllabus that given to us, okay, in the overall process, we have six process, right? Do you still remember? What is the first process? Analyze, analysis, analyze, and then second, analyze is to gather all the requirements, and then what is the second process? After you get the requirement, you start design. No, refer back our process. Okay, like I said that SDLC methodology have a lot, but overall in taking considerations in our syllabus, the overall process. Okay, look back at your lecture note. Okay, overall we have analysis to analyze the requirement, right? And second thing is to design, where we start the design and implementation. So we have design and then development. After we design, we develop, we do testing, right? And after we complete the testing, we deploy it. Okay, we deliver it, deploy is deliver, and we maintain it. 6 process. Okay, so that's the overall of process. Okay, and today we are going to the next phases, which is design, software design. So if we refer back to the process, okay, the first part is analyze, like analyze requirements. So that's why last week we have learned RE. Okay, and the second process is design. That's what we learned this week. Okay, design, software design principle. And next, we start to construct, which is development process. Okay, so it's going back to the process that we learned before. Okay, so remember. But I know some of you think of the plan. First, we plan and then we analyze. That's the general SDLC, right? I believe that you also I'm not sure that there is some subject is introduced the process of SDLC. Okay, but I believe that you have been familiar also with the SDLC, where you start with planning, analysis, and then you design, implement, test, and then maintenance. Same thing, 6 process we go through, right? Just the content a little bit different. Okay, you start with plan first and then you analyze. Okay, so the process is actually about the same. Just if we are talking about the SDLC, design is in analyze process, right? After you gather the requirement, you start to design it, right? But in our syllabus, this is the second phase where we start to design. Okay, so that's why we have this chapter of software design principle. Okay, so in this chapter, okay, we will cover 4 things. Okay, so introduce you the process of software design, and then describe different stages in the design process, and then to show how object-oriented design strategies, and finally discuss some design quality attributes. So what I read in the lecture note is quite different. Is what I learned, or I read from the previous notes. Like I said, that we refer to the book. Okay, the book reference. Okay, so the book here is explaining. I'm not sure because the lecture note is quite repeating. Okay, if you can see, I'm not sure the group 4. Are you facing a similar understand of mine also, because I can see the repetitions. Okay, but actually the repetition is trying to explain more details of the content. Okay, your friend just now, that's why. Okay, I hope that those doing a topic presentation and also sharing the topic, okay, please explore more. Okay, explore the example to make your friends more understand about the topic. Okay, if you just follow the lecture note, you will get same understanding with the one that I explained. So that's why you are the one that have more times, more members to explore more detail of the example. Okay, so that's I'm looking for. Okay, that's why I'm asking you try to put it an example to make sure that the purpose is your friends understand. So far we don't have yet the group that present more people saying yes rather than half, right? So I'm looking forward for the other groups. We will do the sharing later on. Okay, so let's go through one by one. So overall, actually, it's talking about the design process. Okay, design process, principle, attribute, and so on lah. Okay, so as a developer, okay, developer normally like to skip the requirement engineering and design phases. Why? Because they are trained to think that design is wasted of time. Okay, because normally developer is good in programming, right? Good in writing a code. So they think that forget about the design. Okay, wasted of time. Okay, I want to start coding. I want to start develop the system without planning, because design is a part of planning actually, right? Okay, and think of they need to show the result as quick as possible. Okay, and then they judge by the amount. Okay, because people always think that how long that you will complete this project, right? So that's why I said, as a computer science student, okay, you should explain to your stakeholder, okay, what is the process, okay, and if I was giving a times for doing a project, okay, my understanding is focusing more on to understand the problem and target user instead of you suddenly doing the solution and development. Okay, study first. Okay, the problem, what is the main problem, and who is your target users. That's why I love to do a research on user behavior. Okay, if you giving me 1 minute to solve a solutions, I will use 55 second to think of the problem first, and the solution only 5 minutes. Okay, because we have a lot of solution, which one is much more better solution only, right? So talking about the developer, they think of all this, okay, all this reason, okay, judged by the amount ni, is kind of financial. um, how long they can finish early, and then they can continue to the next project, okay, because sometimes they evaluate based on the delivering time, okay, reduce the cost of complete the task. That's why we have a lot of system, but most of the system have not been used by the users. Why? This is why, because they are skipping the important part, okay, the planning and also the design. They directly develop, okay, and again, not only because of the money, okay, line of LOC is stand for line of cost, I think, is talking about the financial, okay, and last one is the schedule is tight. You are giving a time 6 months, so you think that you have a tight schedule, okay. What is not design? Okay, design is not programming, okay, design is not modeling, okay, and but modeling is part of the architecture design, okay. It's not part of requirement, okay, where requirement finish and design start, okay. That's why in the process that we learned before, okay, we have the first process is analyze. Analyze is talking about the RE, requirement engineering, that we learned last week, okay. And now we are in design phase, okay, which is we start design and implementations, okay. So requirement, what is the process supposed to do, design how the so when we talk about requirement is what the system supposed to do. We have 3 level of requirement, remember, business level, user level, and also product level, right? For design is we want to start implement the project by starting to design the how system will be built, how the system should work, right? Okay, so when we talk about design, okay, actually I was think of the design we start to sketch first, okay. Actually there is a few level of talking about the design. We have first level, intermediate level, and also detail level. So first level is normally to make sure that to enable you stakeholder to understand, okay. They come to you to request a system, right? So you do a design to make sure that what your stakeholder is required is same understanding is what you want to deliver. So that's why first level is to enable stakeholder to understand, reason, and communicate the system that you will build later on. So high level model of software system is describing the structure, the functionality, the characteristic, okay, of the software. Make the stakeholder understand how the system works, okay, and allow evaluation, okay, before it starts. And also finally, understood and can provide the tool and techniques before you start the project. You already know what is the tool and technique that you will be used in the development phases later on. So in the intermediate level, okay, the first level is to make sure that your stakeholder understand, right? The intermediate level, okay, is to identify the tools and technique that useful to implement the architecture. So software system blueprint should consist of component, interaction, and interconnection. What is component inside the software? It kind of the actors and also the associate and also the use case that you learned before, right? So if you see this blueprint consists of the 4 elements of the use case diagram: component, interaction, and interconnection, right? That's why intermediate you already identify. Okay, you want to use case, or you want to use a DFD or ERD diagram. Okay, so in your case is use case diagram and also use case description lah. Okay, and we have the next level, which is the detail level. Okay, which aspect software system are architecture relevant? So in this detail level, you already identify the hardware, the platform, okay, and then the relate of requirement with part of the design. Okay, which one is the user requirement, function requirement, non-function requirement, okay, data requirement, okay, and the constraint, right? That's why it's include not only functional requirement, also non-functional requirement. So talking about software design is actually meaningful engineering, okay, because it represents something that is to be built. Okay, design. The word design, you know, right? You design something that's showing that how the end product of the proposed product. Okay, so it should derive a solution by looking at the design. You already know that this is a suitable solutions, or what kind of solution you are propose. Okay, and software design is an iterative process. Okay, it's a blueprint, yes, but it's iterative from the achieving the business level to the user level until the product level. It's an iterative process. Like I said, that if we involve users in the process, we will have a few phases that you have to improve it. Okay, you have to add in, you have to update, and that's why iterative process. It may goes back to the requirement, and then you may to redesign it to fulfill the need or the requirement by the stakeholder. Okay, so design depends on so you know that to have a project, okay, depend on how big is the project, how big is your software that you want to develop. Okay, so it simplify version. Okay, if you're talking about the system, we know that it's link each other. You have a coding behind it, which is complex, right? Complicated. So using a design, you make it more simple to explain the software system. Software design principles. This is stated by Davis, 1995. Okay, this is a theory, okay, a theory from Davis, okay, saying that when we the principle of software design, okay, it should design process should not suffer from a tunnel version, meaning that what we call it it's not too complex. Okay, it's not too complex. You know, tunnel kan macam dalam gua macam tu kan. So it should have more vision, okay, more visual. Okay, the design should be traceable to the analysis model requirement. So by looking at the design, it can be traceable. That's the analysis from the requirement, from the user requirement, or the requirement from the requirement engineering before. It can be traced lah. What is the requirement, and you can see in the design. That's mean traceable. Okay, you can track. Okay, you can track. The design should not reinvent the wheel. How I want to explain, the design should not reinvent. Not reinvent. Should not reinvent. You know the behavior of wheel, right? It goes back. It's iterative, right? It's iterative, right? But it should not reinvent. How I want to explain it? But this is the principle, because you know that the theory is taking from Davis 1995. Okay, I believe that the modern theory is much more easy to understand, because the old theory, are using a difficult word, right? So the design should minimize the intellectual design. Okay, that's why, okay, I love to do UX. Okay, in UX we have a new model, new design that easy for us to understand the word, okay, rather than the old version. But of course, the syllabus is using the old theory from Davis. Okay, this is starting for the principle of software design. The design should minimize the intellectual distance between software and problem. Okay, um, minimize the intellectual. So the problem can be solved using the proposed solutions as in the real world. Okay, the design should exhibit uniformity and integration. So, because why I don't like the theory, because some of it is not relevant for the current situation. Okay, but never mind. We just look into the theory. Okay, talking about the uniform and also the integration. Okay, yes, we want the design should be integrated. Okay, should be structured. Okay, structured to accommodate any changes. Okay. Next, structured to degrade gently, even when you can degrade it, upgrade, even upgrade or upgrade or lower grade kan. So actually this is talking about the adaptability lah. Adaptability is talking about the data, event, the operation, condition, platform. Okay, see the word used is very old lah. Design is not coding. Okay, so this is what in the principle. Yes, coding is not design. Okay, so the design should be assessed for quality. Okay, we can access the quality of the design. Okay, when we talk about the design is have impactful of aesthetic, you can assess. Okay, you can assess the quality of the aesthetic. Okay, the design should be reviewed to minimize conceptual semantic error. Yes. Okay. This is the iterative process. Okay, after you design, you need to review by the stakeholder. Okay, and then get agreement between the stakeholder and also the designer and also developer. Okay, so that we have a same understanding and it can minimize the errors. Okay. Concept in software design fundamental, abstraction, architecture, pattern, separations of concern, informing, hiding, limit complexity, hierarchy, structure, understandable, adaptability. This is the concept lah. We will go through one by one. Okay, if you can see that it will repeat again. Okay, so a design process is from the informal to formal design. Okay, meaning that you may sketch in the low resolutions and then you change to the high fidelity one. Okay, low fidelity, high fidelity, and the one that you can start to do a testing and you finish design. So that's why I said the word design, it's very big. Okay, if we're talking about the SDLC, it's still in the analysis phase. Okay, but when we're talking about our syllabus process, we should already in the phase of designing the system. Okay. Stages in the design process. Okay, actually if you look into the figures on the right side, okay, in the design we have three main stages. Okay, on the design input, where you identify the platform, requirement specification, and also data description. And then we have second level design activities, okay, where we talk about the architectural interface and also component design, where it goes back to the database design. Okay, and finally the design output. Okay, in the system architecture, database spec, interface spec, and component specification. Okay, so this is the one that you may need to highlight. Okay, in software design we have three stages. Okay, three stages that we have: a design input, design activity, and design output. This one is the most important lah. So of course, see, design input they still are in the requirement specification. So actually, we in the SDLC, in the design, we already start the analysis process. Okay, we start to design for the development process, right? But in here, they still mention about the requirement specification and also data description. Okay, so in design input, okay, to gather the requirement specification, you need to understand the problem, okay, identify one or more solution, and describe solution abstract. So actually, the stages here, the design input, activities, and also output is quite similar with the one in the text. Okay, where you problem understanding is in the phase of design input. Okay, and then design activities is you start to identify one or more solution, and finally describe the solution abstract is the output of the design. Okay, and repeat process for each identified abstract until the design is expressed in primitive. Like I said, the design process is iterative. It can be repeat the process, okay, to identify the abstraction until the design the design is confirmed and agreed by the both parties. So here explain about the, if you can see here, actually the architecture design, abstract specification, interface design, component design, data structure design, algorithm design is in the part of which one overall, right? So that's why it make us confused. Before it's talking about the stages, now it's talking about the process where actually it include again all this level, kan? So architecture level, okay, architecture level is actually in this design activity, right? Okay, so architecture design, identify subsystem. Okay, abstract specification, specify the subsystem. Okay, interface design, okay, the user interface, describe subsystem interface. Component design, decompose subsystem component. And data structure design, design data structure to hold problem data. And finally, algorithm design is the coding part. So if you see the figures here, see the architecture, abstract, interface, the one listed, the 6 element here, the 6 process here is mentioning the design activity. That's why it's similar with the one like this one, design activity. So easy for you to understand in this 3 level of design input, design activity, and design output. So this one is quite similar. This is the design activities, and the requirement specification is the one at the above part, design input. Okay, same thing, right? Okay, so and the below part is the output, design output, where it comes with the system architecture, software specification, interface, component, data structure, and algorithm, and all these are linked together. Okay, and from problem requirement definition to requirement specification, determine exactly what, this is just telling you the purpose of design can be explained, can be transformed lah. Design also from requirement to architecture design. Okay, so problem / requirement, define the requirement specification. Okay, specify what the software product is to do. From requirement specification to architecture, you can know how do we plan to build the system, decompose software, and specify high-level behavior, interaction, and non-functional properties. Okay, in transition from requirement to architecture, things you need to consider. Okay, schedule versus budget. That's the plan of management tools that we need to use to make sure that our scope is in the schedule and under the budget. Okay, cost versus robustness. Okay, fault tolerance versus size, security versus speed. Okay, all this need to be considered. Okay, maintain a record of design decision and traceability specific. All these are just explained on the transition from the requirement to architecture. And to explain to you the advantages of explicit architecture. Explicit is digging out, right? Digging out the details, okay? The details of architecture, okay? From requirement to design, okay? From design to programming, testing, and maintenance, okay? Going back to the process, okay? We have analyze, design, development, testing, deploy, and maintenance, right? So requirement to design, design to programming is the development, and then goes to the testing, and then finally maintenance. Okay. Also, the second advantage is for the stakeholder communication. Okay. So in the architecture is the main focus of discussion. Okay. You are start to design the architecture of the system. So this is the one that you communicate with the stakeholder. How many actors, how many use case, this is the part lah. Okay. System analyze means that analysis of whether the system can meet its non-functional requirement is possible. Remember what is non-functional requirement? The constraint, right? You want to have a system that help you to improve the performance, improve the quality. Non-functional requirement that you need to make sure also lah your system meet all the non-functional requirement, which is the constraint of the purpose of the system that you want to develop. Okay, large scale reuse, the architecture may be reusable across. The architecture may reuse for the other project that have a similar process. Example that you want to develop a system of e-commerce but different domain. Okay, e-commerce for clothes and the system, e-commerce for different domains, which is maybe focused on the shoes, right? So it's kind of similar, kan? Just the domain different, so it may be reused. Okay, only the detail of the product, right? So that's the use description lah will be changed. So the characteristic for architecture and system, of course, talking about the characteristic, all the good characteristic, right? So it should be perform, secure, safe, reliability, availability, maintainability, and also quality. Okay. When we talk about characteristic, of course, the good thing, right? It should be perform. Your system should be perform, secure, safe, reliability. You change to other platform, it can reliability, availability can be accessed, okay, can be maintained, and maintain the quality of the good system lah. Okay. In architecture design process, okay, system structuring, the system is decomposed into several principal sub system, okay, to communicate between. That's why when you do a testing, you have a single testing and integration testing where you test individually. Example, the features you test login function, right? You test the search engine, right? And then after that, you want to link the integration. Searching is collect the database from the content inside the database, right? So it should be linked. So unit test and also integrate system test lah. Okay. Modular decomposition, subsystem. That's why in the quiz just now is talking about the modularity. Okay, is in subsystem. Okay, you break into a subsystem. Okay, decompose. Okay, into a module. Okay, so you can create the. That's why when you project normally, we will ask how many module that you will create. Okay. Starting with the roles, okay, how many users role, how many roles of the system will be use the system. So I have two role, buyer and seller, for example. So for the buyer, we have other model. Buyer, you can buy, you can view, you can pay, right? But for the seller, you can update the inventory, different module, right? So modular is breaking the module. So easy for to make sure that the module is in the correct pathway lah. Control modeling, a model of the control relationship between the different part of the system is established. This one, control modeling. How do I give an example? Different part of the system is established. You control. This one is you already identified the actors and also use case. So using the control modeling is it's directly the relationship is using the include relationship. So the actor is related to the use case only. So you have the control of the modeling, and this is most on the authentication system lah kan. You control what the users can do. Okay, we have two role, right? So as a buyer, what is the limitation? Okay, what as a seller, buyer, you only can view after you register, or you only can pay after you register the system. So it have a control modeling lah. Okay, so it normally it's fixed. Okay, it's fixed, and it's hard lah for change. Design quality, okay, when we talk about quality, same goes with the characteristic just now, right? So quality is, of course, good quality, right? Design quality is an elusive concept, should be based on the organization prioritize. Okay, what is the main function? What is the main mission of the organization? Okay, you want to push the seller, you want to increase the the profit, right? So your design should focus more on the process of buying and selling process, much more easier. Okay, rather than you have the reported part, kan? Reported part maybe is not the priority. The priority is to make your users smooth to buy something from your website. Example, a good design, good quality should efficient, cheapest, maintainable, reliable. So orang nak good system, right? But cheapest, kan? Lepas tu boleh maintain lagi, lepas tu boleh reliable, efficient lagi. So you need to define the scope. And quality characteristics are equal to applicable or function-oriented, object-oriented design. Object-oriented is using the use case diagram. Okay, and function-oriented is focusing on the function. You can use the DFD, the context diagram to overall, and DFD, you have DFD level 1, 0, 1, 2, 3, and so on. This is example of procedural abstraction. Okay, natural consequence of otherwise refined. Okay, name of procedure denote sequence of action. Just example of abstraction, the procedure. You visualize the procedure. Okay, the system level, sub level, what the system level and sub level can do, how long it takes. Visualize it. Okay, data abstract aim at finding a hierarchy in the data. Okay, from the complicated data to more general or more simple. Okay, so modularity, we have two: interconnection, either cohesion or coupling. Okay, cohesion is glue that keep a module together, while coupling, the strength of connection between modules. So this one also is break into module. Cohesion, a measure of how well a component fit together. Components should implement a single logical entity. Cohesion is desirable design component attribute, as when change has to be made, it localizes a single cohesive component. So some projects are good to fit together. You change one module, it automatically have affected to others, right? Because it's fit together. We have 4 types of cohesion. Coincidental cohesion, part of component are simply bundled together. Logical associations, component which perform similar function are grouped. Temporal, component which are active at the same time are grouped. Procedural cohesion, the element in the component make up a single control sequence. So in cohesion, we have 4 types that weak the cohesions, even though it's fit together, it's because bundled together, right? One system is been hacked, it will can goes to the other system. Okay, you break one and then you can go for the others database also. Communication cohesion, much more medium level. Okay, all the element of the component operate at the same input or produce the same output. Sequence cohesion, the output for one part of the component is the input to another part. Functional cohesion, each part of component is necessary for the execution of a single function. And lastly, strong is object cohesion. Each operation provide functionality which attribute to be modified or inspect. So the good one is this one, the two, strong, functional, and also object cohesion. That's why they mentioned about the functional function and also object oriented. So each part of component necessary for execution with a single function. You are not tied together, right? So the second one also, one attribute need to modify or inspect, operate differently lah, different based on the functionality. Attribute in design, okay, not well defined, often difficult to classify cohesions. Inherited attribute from superclass weaken cohesion. To understand a component, the superclass as well as the component class must be examined. Okay, you will think that I was explaining in the fast because I don't think that it's important. Okay, just for knowledge only. Okay, the only part that when I mention in slow explanations kan, this one is we can have a common sense. Okay, remember later on kan, what I know about your test. Okay, you will given open textbook tau. Okay, but you cannot Google. Okay, you can open your lecture note. Okay, you can open lah your notes, but you cannot use your Google. The question is not directly. It will give you case study that you must understand. Okay, to use the content to answer the question. It's not directly what is non-functional, what is functional requirement. It's not just directly, it will give you adalah the corner-corner sikit. Okay? But the answer is there actually, just to make sure you understand the logic of the question. Okay, this is the design concept of coupling. Okay, this is uncoupled, this one loose coupled, and this one is tight coupled. So the word tight, loose, uncoupled, you can understand lah. A measure of strength of the interconnection between the system component. So the tight is good or better? Good or not good? So it depend of the system lah. Okay. Okay. Next is coupling and inheritance. Okay. So object-oriented system are loosely coupled. Okay, normally when we talk about object-oriented system, it's loosely coupled. Okay, but it have a object class. Object class coupled to its superclass. Okay, so what to say? Information hiding. So this is explanation on information hiding. Okay, each model has a secret. Design involves a series of decisions. Okay, information hiding is strongly related to the abstraction, coupling, and also cohesion. This is only the concept. Okay, concept of information hiding, the complexity, top-down design, understandability, adaptability. Okay, just you need to understand the overall definition lah, the general. Adapt, of course, it can adapt to a few situations, right? Understandable, the design can be understand in several component character, cohesion, naming, documentation, and complexity. Top down is mostly macam top management punya they already have the function and functionality that you need to provide to your system. So normally it's kind of like that one lah, top down design. Okay. Okay, key point. This is a summary lah. So this is important. Design is core for software engineering. Okay, when you start to develop a software system, okay, you need to have a design because this is the core. Okay, so design is a creative process. Okay, because of the creative process, okay, so it have a visual view. Okay, visual view to simplify the explanations from the complex explanation of the system into the simplify of the visual explain. Okay, so design activities will include architecture, system specifications, component, design, data structure, and algorithm. So remember, that's why I said design is very big. Okay, when I talk about design, I know the first level is using the use case diagram. Okay, you want to visualize the requirement to your stakeholder to make them understand. Okay, when we go to the intermediate level, okay, intermediate level is you more specified on the architecture design, system specification, component design, data structure design, and algorithm design. Okay, but in the design process lah. But goes into the detail design. Okay, you already show us the interfaces, the interfaces of the detail of the requirement just now. So it goes through the process by the process lah. So design concept provide the basic criteria for design quality. Okay, that's why when we have a design, we have low fidelity and high fidelity. Low fidelity, it can be a sketch. Okay, it can be only a diagram. Okay, but high fidelity, you have the interface. Okay, with the the correct function. Okay, it can shows all the function in the interface. That's why we have the definition of low fidelity and high fidelity. Modularity, abstraction, and refinable enable design simplification. Okay, using modularity, abstraction, and refinement, make the design more simple. Okay, where you break, you can draw in the diagram. So you break into the modularity, abstract, view it, and refine it to modify based on the requirement. A design document is an essential part. Okay, normal when you propose a project, right? Before you start implement, you have the design process. Okay, from the requirement that you gather, you start to analyze and show it in the design, show it in the design, which is in the visual. Mostly we are using the use case diagram. Okay, and then we goes to the high federation of the user interface design and also the the behavior of the system lah. That's all. Okay, so again I repeat, software design process, not coding, and coding also not a design. So it's different meaning. Okay, coding is coding, design is design. Okay, why design important? Why design important? It's showing a meaningful, showing a solution, showing the blueprint. Okay, and design have an iterative process. Okay, you need to also remember there are 3 stages in the design process where you have the design input, identify the platform, requirement specification, and data description. And then next stages is design activities where you have the architecture, interface, component. Okay, and finally design output. Okay, what the system architecture, the database specification, the interface specification, and also component specification. Okay, and normally because your syllabus is using the object-oriented design strategies. Why? Because of the loose coupled, but you can I'm not sure. I think yes, it's in the lab. Okay, we use a use case diagram, and later on you been introduced activity diagram, and then you have the sequence diagram. Okay, so that's what we will do in object oriented strategy lah. Okay, what else? I think that's all. The most important part is we have 3 level of design. The first level is to make sure that you understand, to make your stakeholder understand, right? And then you have intermediate level where you identify tools and techniques, and the detail level is where you identify all the requirement, hardware, software, and so on. Okay, and then the stages just now, design input, design activities, and design output. So that's the overall of talking about the design. So design ni besar. Sebab itulah saya cakap di mana is referring to the chapter 2. Chapter 2 that we have learned on the process. So you have 6. In general, in process and also SDLC, we have 6. So in the syllabus of your process methodology, you have starting with the analysis, the requirement where you learn last week, requirement engineering. And this week is the second phase, the design. Okay, so design include design input, design activities, and design output. So the most important part is the design activities, where you have the architecture, interface, and also component design. All these are related with database design. Boleh faham? Okay, and next week, not next week lah, after the topic of system design, you start the development, where system construction. System construction is development process lah. Okay, boleh? Okay, saya rasa sebab kurang susah sikit lah nak apa ni, because there is a lot of information is telling you why kan, why, how kan, rather than directly what you should know kan. So I make it more simple. Okay, you should know the stages, level, okay, the quality, and also the characteristic. You know the good characteristic, the good quality should be adaptability, understandability. This one is make sense kan, macam general info. So you should know lah. Okay, boleh? Diorang semua jawab boleh. Okay, good. Okay, good. Hopefully, that's why I said the content here is general. Okay, general. Boleh. Okay, good. Okay, boleh. Okay, hopefully memang boleh. So hopefully you already change from half to yes kan. So that's normally it's like that because it's repeated. They explain more and more. Okay, that's why I would love if your friends could give example. So susah lah saya nak fikir semua example kan. So it's good for your friends is doing explorations. Okay, saya tak tahu group 4 tadi. Hopefully you understand what you are presenting because the way you present is just reading. So hopefully you understand. Okay. I think that's all what I want to add that more. Okay, and the stages just now, okay, the design input, design activities, and design output is equal with the input is the problem understanding, right? And then design activities is to identify the solution, okay? And then the design output is describe the solution in the abstraction lah, in the visual way lah maksud dia, kan? Okay? Any further questions? That's the important part lah kan nak tanya. Okay, again, okay, overall of until we are now in week 6, dah week 6 dah. So you start being introduced what is software engineering, right? Okay, and then second chapter is introduced to the process. Okay, remember the process. Nanti you tak complete dengan the next chapter ni tentang apa. Kalau you faham process, you can relate. Okay, so in process we have 6. Same with SDLC actually, but normally I explain in SDLC easiest kan, planning, analysis, design, implement, deploy or delivered, and testing, and also maintenance. But in our syllabus, okay, you also have 6. But okay, it start with the analysis. Okay, that's why we have requirement engineering, and then we have design. That's why we have system design principle. Okay, and next we have development, where you have system construction. Next, we have testing, where you have system verification and validation. Okay, something like that. And next, we have the deployment, evaluation, system evaluation. And lastly, the maintenance. Kalau FYP tak adalah sampai maintenance kan. Okay, but this is the overall process of software engineering. Okay. Nanti relatekan balik dengan proses, you boleh understand why we learn chapter by chapter. Okay. Like again, I want to remind you, okay, you need to explore kan, because of the question later on it's not directly give you objective punya question. Dia tanya define, the answer is there, right? But dia ada case study yang you need to think of the reasonable. Okay, that's why dia kata open book. Sebab soalan tu tak semualah, tak directly you can get from the notes. Okay, you need to think. Okay, so that's why when you learn each chapter, okay, I love read your self introduction. Some of you define that you like to do a surfing internet, right? You want to explore more. So this is the time, not by reading the lecture note. You need to explore more. Okay, actually we have a lot of design principle. Okay, I love to do UX principle. Okay, it's more clear lah. We have follow the basic of actually we have 3 guru lah. Shidema, Norman, seorang lagi. Itu 3 tu. Our guru of UX. Okay, alright. Any question? Ada soalan? Boleh faham? Okay, kalau tak ada, I think that's all for today. Topic of software in design principle. Okay, again, I want to no question. Okay, good. Okay, we will do revision after your mid-sem break. Buat awal-awal pun tak guna, nanti lupa kan? Betul tak? You all ni bukan boleh ni banyak makan semut ke apa? Jangan makan semut. Okay, so pilihan raya. Okay, happy voting. Okay, happy holiday, mid-sem break. Okay, tak pasal-pasal ada 2 minggu cuti kan. Okay, nanti towards the December you ada apa ni, perayaan. Cuti perayaan lagi. Wow. Okay, you all very heaven in UiTM. Very, 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 very banyak cuti. Okay, but lecturer don't have a cuti. Okay, but we can take a leave lah when you don't have a class. Okay, the good thing is you guys lah. Alright. Thank you, everyone. Oh, before I forget, okay, actually we complete 6 weeks. I want to do a reflection for our class. You can give an input anonymous without putting your name. Okay, reading your input, maybe I can try to improve some part, right? Because talking to myself, I'm not sure that you clearly understand or not. Okay, hopefully lah. The main point is to make you understand, right? Okay, but who knows? You have a good propose of method that what we might improve. Okay, so wait, let me give a link. Okay, this is a reflection from the week 1 until week 6 so far. What you have learned. Okay. Please answer these questions. I hope everyone can answer this question. So hopefully I can get 53 response because our class is included both group 53. Okay. Let me give the link. So I will open the reflection 24 hours. Okay. Instead of I post in the chat box, I will post in the group again to make sure that you complete the reflection. Okay. Just put any thought, okay, or any suggestions what we can make our class more fun ke, kan? Who knows if you think that now we are not having a fun class, kan? Okay, so I'm looking forward for your input. Alright, so thank you everyone. Happy voting, happy holiday. Bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.